Gui program. So we started with a console application, and then we talked about Gui programming. And in the Gui programming, we saw that there is a kind of event manager, and event manager manages events, and it is in modern application it is also called application, or in Qt it is called Q application. And a program which if an application which has event manager, it can create multiple windows, and multiple windows need to be registered with the event queue manager. So event queue manager registers windows, created windows, and then whatever event it receives, event has stamps of event type and window it belongs to. So since windows are registered with the event queue dispatcher, and each event it receives, it dispatches from the event queue has window ID, so the event goes to the respective window owners, the window owners who creates the window. It registers window with the event queue manager. Event queue manager sees the events, and event has window ID, and it forwards the events to the respective owner of the window. Now, respective owner of the window, against each event it has callback function, and callback function will be called. So if we see the typical X server programming, then each event will be kind of popped out from the event queue, and respective window handler will get called, and against the window handler we have the event handler. Or if we go for object oriented programming, then against each window there is a class, and inside the class, for against each event there is a function and associated callback functions. So finally the end result is, when event comes in event queue, then event finally reaches to the window owner, and then event callback types, event callback function. So event callback, for each event there is a event callback function. So there it get executed. Now we talked about X11, X or X server, display server. So this kind of architecture where X server is a heavy guy that may reside on the same machine where the applications are running. They are called X client, X11 client. So X11 client has event dispatcher and all the window created. So X server, display server can reside on the same computer, or it can reside on the dedicated server. Now X server, it connects with the device drivers, and it receives the events. So this is the original X program. And once it receives the event, then it structures the event from the sequence of bytes, and display server or X server, it also kind of that is the main process that is run. It also manages one guy called window manager. So there are two guys to manage all the X11 clients, X server and window manager. So X server is the main process, and it has a helper process called window manager, and window manager make a bookkeeping for all the windows actually created. So X client which receives X client which needs to create a window, it goes to Windows X server. First it registers with the X server, and it receives a display data structure, and then based upon the display structure, or in reference to the display data structure, it requests for the window creation. So there are 10 X client applications are running. They may register a window creation 20, 30, 40. They know how many they have requested. They have data structure. And X server, while creating the window, it informs the window manager. Window manager keeps the booking, where the windows are, it is in minimized state, maximized state, and those kind of things. And X server receives the event, it structures the event from the byte sequence, and then with the help of window manager, it embeds a window ID also, and then either it passes it to respective X11 client, or X11 client fetches their events based upon their display data structure. And then same story, how it goes to the event callback functions. Now we'll see more on it, how it works. So X11 server, that is residing either on the client machine or dedicated server, it has bulk of tasks. X11 server, let's see that how if user click something, then he expect some graphics change. Now X server receives the kind of the events, and event are structured with the window manager, window ID is pushed in, and then event goes to event callback function running on the callback function that is on X11 client. There it decides that based upon the click what would be the graphic changes on its window. So every window has a display buffer. So what kind of changes it expect. So display buffer in the sense that the video buffer we can see. For each window there is a video buffer. Now the event callback function, it decides for the video kind of changes, like one dialog box would come in response to the click. So because that event callback would be knowing. So when event callback decide that this graphic should change, so every window, if there are 20 windows, then 20 buffers are there. Now for a particular window, what changes should happen in the buffer? It creates a rendering request. Means I need a dialog box. Rendering request is sent back to the X server. Events from the hardware coming to X server. X server with the help of event window manager, X server formats the event. It pushes the window ID also with the, because window event position, everything would be there, which window is there at those, because window manager knows everything. It keeps the bookkeeping. Now window ID is pushed, sent to the X11 client. There in the event callback function, it is decided that for that particular window display buffer, some new graphics should come. It generates a kind of rendering request, sends to the X server. X server does the rendering per window. Per window buffer, it does the rendering. And then it sends to rendering. After doing the rendering, then it sends to window manager for the change in the bookkeeping. Once changes come, then final desktop need to be drawn, because the desktop has so many windows. And then X server does that also. And then it sends, then it uses the graphic device driver, and finally it comes over the screen. So this, since X server does bulk of job, so this is actual X server. Now the problem happening is day by day new kind of softwares are coming, and they are very small. Like if someone needs to draw on a window display buffer, then OpenGL is capable of doing it through DRM, direct rendering model. So through that OpenGL itself, so like eGL came, embedded graphics library, or GL is graphics embedded system 2 version. So these versions, with the help of DRM, they are capable of drawing on the window buffer itself. X server role is not required. Now from the byte sequence, what is received from the hardware, from the device driver, converting it to event data structure, EVDev came, that kernel module EVDev, that was much better. Okay, there are font support. For X font were famous. For that free font support, means extra font support came. 2D graphics, 2D drawing, for that Cairo came. Okay, so now so many things, whatever X server is doing, for that dedicated nice modules came. So this is kind of open source era, things started changing. Now X server is not doing anything, means everything. Now for the overlay, the final when it goes to the kernel for the overlay of the desktop, for KMS kernel mode setting. So Nothing is required for them. X server is becoming obsolete slowly. It starts becoming obsolete. And then the final desktop management in the display buffer, the video buffer, screen buffer. So that not the window buffer, full screen buffer, that is managed by again X server. Now it went to window manager also, window compositor. So they start saying window compositor. So all roles and responsibility from drawing to each window buffer, to desktop buffer, to font support, to 2D acceleration graphics, to event changing the device driver, hooking to device driver, receiving the event from the peripherals, as a sequence converting it to event data. So all are distributed now. So not required. Means X server, why to use X? So new fundamentals start coming called Wayland. So Wayland is a kind of another utility. So they call it, instead of window manager, now it is a Wayland compositor. X server removed, not it. So X server completely removed, and window manager, new name Wayland compositor, it replaced X server. Now there is only one entity, that is called Wayland compositor. So now X11 client connected to X server, now it became Wayland client. So Wayland client connecting to Wayland server, Wayland compositor, and Wayland compositor is talking to KMS and EVDEV. That's it. So this is the new architecture, that is Wayland architecture. So what Wayland provides? Now Wayland main job is to kind of delegates or manages all the open source modules like KMS, means all the new available modules, kernel modules like KMS, EVDEV, and then Cairo, and then fonts, and then EGL or GLES2, and then only thing it requires to be done, that the window X server was doing the desktop buffer management. Now it came to Wayland compositor. That's it. So Wayland compositor, what X server was doing as a desktop display buffer, screen buffer management, that came to Wayland compositor. Otherwise, it is just managing here and there. Now, when event comes in, then event comes through EVDEV data structure, and EVDEV event data structure goes to a Wayland compositor, and a Wayland compositor, then since it is managing windowing, it pushes window ID, and then events are going to Wayland clients, and Wayland clients in its event callbacks, it is drawing to the window display buffer on its own through EDL library. It is not dependent upon, it is not generating a kind of a request. So earlier it was generating a kind of a display request kind of a stuff to that with the X server, that what need to be drawn. Okay, so that request, what it was raising to the X server, so that request it is not raising. So it is drawing in the display in the window display buffer on its own. So that is something that is different now. So using the EGL library or GLES2 library, it is drawing on the window buffer on its own. All clients, Wayland client. Wayland is providing its kind of C APIs for doing that. Means it mixes with the EGL API, and then it draws, and then it communicates with the Wayland composer. Wayland client, when it receives the kind of events, if anything need to be drawn using the EGL or GLES2 API, it draws in the window buffer directly, and then it uses Wayland protocol. It kind of it now Mesa and those packages, they are built with the Wayland, and then it communicates with the Wayland compositor through the new protocol what Wayland is providing. Now Wayland is receiving the idea that which buffer has the data. Window buffer may not be unique. It may kind of bring in new buffer at all. Okay, so means client which is writing to the in response to the event, it may not write on the same window buffer. Otherwise, it would fluctuate. It means compositor and client one is writing, one is reading in between or something like that. It may come up with a new buffer at all or some back buffer where it would write and informs the Wayland compositor that this is the buffer now. Now Wayland, since it is a compositor, now it has received all the buffers from all the clients which changing their Windows buffer. Then it accumulates and it draws the desktop. Okay, so when Wayland draws the desktop, then it is kind of then it uses finally the KMS for the final overview. Okay, so this is a kind of new idea that Wayland came. Okay, so things have changed. So earlier the kind of this in X server architecture, X client used to send the graphics request to the kind of or display request to the X server, and X server kind of it was then so it was doing all the job. Now it is being done by the final. It is also called a damage event. Damage event is a term that slowly it was it is used like when there is a Wayland compositor and there is a Wayland client. So client is doing all the rendering into the window buffer, and then it sends a damage event to the Wayland compositor through the Wayland protocol. So actual term is a damage event. So damage event, earlier X clients who used to send the display request. Okay, so graphics request or display request, and now clients are sending damage event, means this was damage is requested, and then a compositor they maintain the event queue, compositor they maintain the desktop, and there they finally accumulate all the changes in the final screen display buffer, and then using the KMS in the kernel, then finally it comes to the screen. So this is new architecture. Very nice in the sense that X server headache gone, and how kind of it comes into the picture in real picture. So Wayland compositor can be standalone server, or it can be kind of it may not be there in the sense that we'll see that. Now, what about the backward compatibility? So now we have kicked out X server and Wayland compositor came. There is no window manager. The window manager become Wayland compositor. X server kicked out, and all the work are happening. So the main work of drawing in the video display, video buffer went to X client. So what about backward compatibility? If there are really old X11 clients and they are not building up with a Wayland library, then how they work? So Wayland can instantiate X11 server for the backward compatibility, but Wayland compositor will connect to the kernel, not the X11 server. So X11 server itself is behaving like a Wayland client. So Wayland client and X11 server all are Wayland client, and X11 server will have its X11 client. So X11 client, they will work with the X11 the way they used to work, and X11 whatever, now it's a headless, there is nothing in the X11. So whatever X11 is receiving, it is finally passing it to the Wayland compositor. Wayland compositor is talking to KMS and EVDev in the kernel. So this is for backward compatibility. Where it is available, so new Debian called Bookworm. So that is the new version of the Debian. So they full-fledged now Wayland is available, and desktop is running on the Wayland, all Raspberry Pi, new bookworm. So all are Wayland compositor based. So this idea, okay, can we do more? So in kind of embedded environment like mobile, where there is no multi-windowing system, means only one window is there. If I open another app, then or any embedded area where multiple windowing is not required, there we can remove it and anyway Wayland client itself has Wayland API, so Wayland client can run on its own. Means they will talk to device driver, because anyway all are now integrated with the Wayland library. So Wayland client is also enough. Okay, so what we saw now with the change architecture, Wayland is opening its hook, Wayland compositor. So X server and window manager, then X server and window compositor, they merge together and become Wayland compositor. X11 clients, now they become Wayland client. And X11 client, when they receive the events, they draw using the EGL or EGL ES2 library directly on the window buffer. And then a damage event is sent to the compositor, Wayland compositor. Wayland compositor manages the display buffer, screen display buffer, and then for the overlay it goes to KMS and it comes. So nice for backward compatibility with the old X11 client. It can instantiate X11 server, the old X11 server. But X11 server would become like a Wayland client to the Wayland compositor. So Wayland compositor is now still the main guy, and it is available as a bookworm, that is a new release from the Debian. And for the embedded area where not multiple windows are required, Wayland client is also enough. For Wayland server is not required. So this is the big thing, big boost up in the kind of drawing to the screen and managing the video buffer. So main fight is happening on maintaining the video buffer individually by each client separately. So every client now they can draw on their window buffer separately. So that is in their control, not in the X server's control. So nice. This is the new world where everywhere new libraries are coming up. So the modules, the software which are able to manage the new library, they are coming up. Like Kiwi is a Python-based graphics library. They are managing all the libraries. Like for the image, they are they have PIL. They are using PIL for FFmpeg for the video. Like that, there are so many libraries are there. They are just delegating the call here and there. Like that, Wayland compositor is there. Only thing is that it is doing the final screen buffer layouting, means window full desktop management it is doing. Otherwise, it is just sending the request evdev, KMS, EGL, GLSL2 and then to Cairo and then to otherwise everything was being done by the Excel and it was a heavy. Now this is the new era, so new concept with the Wayland compositor.